showing you some of the basic paperwork. Need a piece of paper, pad of paper, calculator, test information, and then your the form for figuring out your math and your test meter calibration. Right, this is a Neptune Protectus, HP Protectus 8-inch fire service compound. It's got an 8-inch main and a 2-inch bypass. So in this test, we're going to be testing low flow, which will be like 2 gallons a minute. Then I'm going to do another test about 15 gallons a minute. Then on up, I would say 50 to 70 gallons a minute, and then from there you can do 150. You're going to have crossover, which crossover is where it switches, or starts, the water starts flowing through the main line and slowing down to the bypass. And your accuracy can be reduced in the crossover environment. I believe AWWA says 85% minimum in crossover. It's a calibrated test meter. It's a Mars. And we've got, let's see, this side is your low flow, which I use the low flow up to 15 gallons a minute. And then this side is the main line, which is I believe it's a 3-inch assembly. I'll usually start that around 50 gallons a minute. And that'll go up, I think we can run up to about 250 gallons a minute on this assembly, but I'm not going to do that. Not that high. I try to run the range of either standards or the range of what I think the customer is using by watching their flow, the average flow on their meter. Okay, I don't know how easy it is to see, but the larger number is your gallons per minute, the 2.064 so on, and then the smaller number in the upper right is the total flow since you start the test. And on this case, you know, standards vary depending on what city it is, but we're going to run for a certain amount of water at 2 gallons a minute, and then we're going to compare the total. Like if we run, we'll say 20 gallons, then we're going to compare the total of the 2 registers on the test meter, or the tested meter, and then run the calculations factoring in the accuracy of this test meter to determine the percentage. So here's a 2 gallon per minute test. We flowed 20 gallons. So we got 98.6, which is within the standards of 95 to 101. So now we're running 15 gallons a minute. Sometimes the pressure changes and you gotta tweak it up or down a little bit, changing your flow to try to get as close to 15 as possible. So here's the 15. Also notice that we're only getting flow on the bypass, the 2-inch at these low ranges, so there's nothing on the main line. When we have the total, then we calculate what the test meter showed, and then we factor in the accuracy of the test meter provided by the manufacturer of the test meter for that flow range. And then we do the math and we come out to 100.7, which is still within the tolerance, 98.5 to 101.5, because it's a disc meter. Now we're using the main line. At these higher flow rates, you're not going to get exactly at a particular number. Here's a better example without the vibration. Tap it. So 70 gallons a minute. Flowed 1,000. Got 101 on the test meter, on the accuracy test meter, and then we got 976.70 on the meter that we're testing. And the Mars's accuracy number is 99.8, and so that gives us 97.3, which is above 85%. So that's actually pretty good. So that's okay. Next flow is 150 gallons a minute. So for the 150 gallon a minute test, the last two flow rates we were getting mainline activity. So we ran on the test meter, ran 2,005 gallons. The total of the tested meter, the Protectus, is 2,012.3. The test meter accuracy at 150 gallons a minute is 99.91, which gives us 100.22. Which is within the range. So we're going to do these 4 flow tests, and this meter's good. It's also important to note that when you're using a test meter that has a turbine, that your pipe, your hose coming into it should be straight so that the water comes in straight. Not like bent where your hose is like bent over here and it's coming in at an angle, because that can cause the turbulence in the water, causing it to either speed up or slow down the turbine inside the test meter, depending on how the water is approaching or hitting the turbine. All right, so the purpose of having the purpose of a compound is to accurately detect and record the flow over a wide flow range. The main line does not do a very good job reading low flow. For this, I would probably say it really wouldn't do a good job of reading less than about 10-15 gallons a minute. So they have the bypass, and the bypass, this particular bypass, is a 2-inch T10 series nutating disc meter, which should get down to about half to three-quarter gallon a minute flow accurate, but anything less than about a half a gallon a minute, it's not going to record much. It might still record something. So the way this works is low flow, there's a check valve right here in the main line that's closed, forcing all the low flow water through the smaller 2-inch meter for greater accuracy. There's also a restrictor valve right here that, as they start using more and more water, it will push on this restrictor valve and it'll start closing, and it'll slow the water down here and cause the water to want to push and go through the main line more. That way the main line only gets usage under higher flow rates. And I would probably say this main line here would start recording flow somewhere around 30, 40, 50 gallons a minute. It seems like a lot of these Protectus have their own personalities, and some of them, their crossover is different depending on the assembly. So if somebody's running like 100 gallons a minute through here, by the time you get up to 100 gallons a minute, a lot more of it's going to be going through the main line, and maybe you might get like 80 gallons a minute through the main line and 20 through the 2-inch. And then, all right, so I got cut off there. So at high flow, you'll have like, potentially, if so you're using 100 gallons a minute, you'll have 80 gallons going through the main line and only 20 gallons going through the bypass. And then as it slows down, the main line will slow down, and then more of the water will start going through the bypass as it goes downward through crossover and back to where the main line is shut off, or not. The check valve here is closed, forcing all the water through the bypass. So that's just a little basic quick demonstration as to some of the process of a large meter test. Thank you for watching. I also want to say that testing procedures vary by department, by cities, states, counties. So some of what you saw here might not apply to your city, county, or state. So just wanted to put that in there.